Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you are right now. Welcome back to my channel, ASKnowlin, and today we're going to do part 2 of the use of the elimination method to solve systems of equations. So let's go ahead and hop on in. All right, so today, like I said, we're going to extend what we were talking about in the previous video for the use of elimination. Before, we were only multiplying one of the equations by -1, or we just had to add the opposites. But today, the coefficients are not going to be matching, so we're going to have to multiply by a number other than 1 and still keep the coefficients opposites, okay? So let's go ahead and take a look at number 1. Number 1, the first equation is x plus 3y equals 6. Number 2 is 2x minus 3y equals -1. Now, we get to choose which variable we want to eliminate. For the sake of this problem, I'm going to go ahead and choose to eliminate the x variable first. And to accomplish that, I need to multiply everything in the first equation by -2, okay? So when I do that, I'm going to multiply everything in the first equation by -2. So my new first equation should be -2 times x is -2x. -2 times positive 3y is -6y. And -2 times positive 6 is equal to -12. Now I can rewrite the first equation and just simply add the two equations now. So the second equation is 2x minus 7y equals -11. -1. Now we can just go ahead and add both equations. When we add opposites, the numbers are going to cancel out. They're going to equal 0. So when we write this, -2 plus positive 2x is, -2x plus positive 2x is 0. -6y plus -7y is -13y. And -12 plus -1 is -13. Now from here, if you've already watched my other 2 videos on systems of equations, once we solve for y, we're gonna just substitute that variable, that answer back in for that variable and solve for the other variable. So to continue this simply becomes -13y equals -13. Divide both sides by -13 and y becomes +1. So y is equal to +1. Now I'm just going to plug that back into one of the equations and solve for x. So I'm going to plug it into the first equation. The first equation reads x plus 3y equals 6. So x plus 3 times 1 equals 6. X plus 3 equals 6. We subtract 3 from both sides. That gives us x is equal to 3. So now our solution here is +3, +1. All right, so let's take a look at another example just in case, you're still kind of trying to figure out what exactly we're doing with this type of elimination. So let's take a look at number 3. Now, once again, with number 3, we get to choose with any of these questions, we get to choose which variable we want to eliminate. For the sake of this problem, the x coefficients, one is 3, one is +5. We could choose to eliminate that, where we would have to multiply both equations by some number right now. We want to choose the route that is that's the least amount of work and it's going to be efficient for us to solve the problem. So looking at the first equation, the y is -1, and the second equation, the y is +4. I can turn that -1 into a -4 by multiplying by 4. So with that first equation, I'm going to multiply the whole first equation by +4. When I do that, +4 times 3x is 12x. +4 times -1y is -4y. And 4 times 14 is 64. No, 56, 56. But let's double check that real quick. 14 times 4, that's 16, carry that. 1 times 4 is 4, plus that, 56. All right, so we good to go. Now, the second equation, we just rewrite that one. That's +5x. that's positive 4y, and that all equals positive 12. Now, remember, when we're using elimination, one of the variables' coefficients have to be opposites. Well, if we look now, the y's are opposites. One is negative 4, one's positive 4. So we can go ahead and add. So when I add positive 12x and positive 5x, I get 17x. When I add negative 4y and positive 4y, that gives me 0. And when I add 56 and 12, that makes 68. Now, we just continue solving for x. So that becomes 17x equals 68. And we divide both sides by 17. And 68 divided by 17 will equal 4. So x is equal to 4. Now we plug that back into one of the equations. I'm gonna plug it into the second equation. So the second equation is 5x plus 4y equals 12. So now that becomes 5 times 4 plus 4y equals 12. That becomes 20 plus 4y equals 12. We subtract 20 from both sides because we want to get the 4y by itself. So that becomes 4y equals positive 12, negative 20. That makes negative 8. And then now our last step, divide both sides by positive 4. And negative 8 divided by positive 4 is negative 2. So now we have our solution. Our solution is positive 4, negative 2. And let me rewrite that. My mama taught me to write, make sure my handwriting was a little better than that. There we go. So positive 4, negative 2, that's the solution for number 3. All right, so these first two examples, the route and the method or the efficiency was pretty quick, okay? We only had to multiply one of the equations by either a negative or positive number to create the opposite coefficients. When we take a look at these next two, we're gonna have to multiply both the equations, or maybe one or both, by two different numbers to achieve getting the opposite coefficients. So once again, remember, we always want to choose the route of least resistance when we're doing mathematics. We want to be efficient. We're not necessarily trying to be done first or the fastest. We just want to choose the route that's going to get us to our solution with the least amount of struggle. Okay, so for number 7, when we're looking at these two equations, the x's, one of them is 3, one of them is 7. To get those to match, we would have to multiply the 3 by negative 7, that makes negative 21, and we can multiply the 7 by positive 3, that makes positive 21. But then we have to multiply everything else, so we got to essentially change both equations. Now, if you look at the y's, one of the y's is positive 4y, the other y is positive 8y. Now, with that being said, we know that we can multiply the 4 by 2 and it makes 8, but we need it to be a negative 8. So the best choice here is to multiply the first equation by negative 2, and then we'll have opposite coefficients for the y term. So let's go ahead and take a look at that. So multiply this by negative 2, the first equation. Negative 2 times positive 3x is negative 6x. Negative 2 times positive 4y is negative 8y. Negative 2 times positive 6 is negative 12. And everything in the second equation, we just bring it on over. Positive 7x, positive 8y, and the positive 10. Now we can add everything up. So when we do that, negative 6x plus positive 7x is positive 1x. Negative 8y plus positive 8y makes 0, and negative 12 plus positive 10 makes negative 2. So essentially we have 1x equals negative 2. We divide both sides by positive 1. Negative 2 divided by positive 1 is negative 2. So x is equal to negative 2. Now we just continue to repeat our process. Plug it into one of the equations. I'm going to plug it into the second one. Second equation says 7x plus 8y equals 10. So 7 times negative 2 plus 8y equals 10. That becomes negative 14 plus 8y equals 10. we're gonna add 14 to both sides, and when we add 14 to 10, that makes 24. And obviously the last step here is to divide both sides by 8, positive 8. 24 divided by 8 is 3. So y equals 3. Our solution here is negative 2 and positive 3. Okay, let's go ahead and work on this last one, and then this lesson will be over with. So let's take a look at number 8 now. I'm gonna have to use some different colors here. So for number 8, when we look at both of these expressions, we're gonna have to manipulate both equations. Okay, we can't multiply one equation by a number to get the coefficient of the second equation. Okay, we have positive 3x plus positive 3y equals positive 9. Then we have positive 5x plus positive 4x equals 10. For this one, I'm gonna go ahead and choose to let's choose the x's. We'll just choose the x's. So I'm gonna multiply the first equation by negative 5. I'm gonna multiply the second equation by positive 3. So negative 5, multiply everything in the first equation by negative 5. Multiply everything in the second equation by positive 3. And now we're gonna rewrite these equations. So that's gonna become negative 15x minus 15y equals negative 45. This is going to become positive 50. Oops, let me use my green. This is going to become positive 15x positive 12y equals positive 30. Now we can go ahead and add. The x's are going to cancel out, make 0. Negative 15 and positive 12 make, negative 3y, right? So put a minus 3y or negative 3y. And negative 45 and positive 30 make negative 15. That's essentially going to give us negative 3y equals negative 15. Divide both sides by negative 3. Negative 15 divided by negative 3 equals positive 5. Now we just plug that positive 5 into one of the equations. I'm gonna plug it into the first one. So the first equation says 3x plus 3y equals 9. So that's 3x plus 3 times 5 equals 9. That's 3x plus 15 equals 9. We subtract 15 from both sides. That becomes 3x equals negative 6, and when we divide both sides by positive 3, x equals negative 2. So for number 8, our solution here is negative 2, positive 5. Final answer. And that will conclude our lesson on part 2 of the use of elimination to solve systems of equations. I'll holler at y'all later. Deuces.